Now let's move on to the second step. The second step is to find out address for page table entry. Once we get to know the address for the root page table, so we need to find out the address for page table entry in the root page table. For this, we need to refer to the level 1 index. Level 1 index is placed in the 30 to 38-bit position in the virtual address. So if you convert the virtual address into the binary, the format, so we can have those kind of information. For better understanding, let's refer to this example virtual address. This virtual address is in hexer format. This will be converted into this kind of binary format. Based on this layout, 30 to 38-bit position, we can have this binary value. This binary value can be used as level 1 index. But this binary value can be converted into hexer format. And here is the hexer format, the value for this binary value. So if you multiply the value by 8, so 8 is the word size in the RB64, we can calculate offset address. So this offset address will be added to the address of the root page table. Here, finally, we can reach out to the address of page table entry. This is the important step to find out the address for page table entry. Once we reach out to the page table entry, we can identify the physical address for next level page table. So this job can be done using several bit shift operation. Let's break down this operation in more detail. Here is the layout of the page table entry. As you know, the page table entries is split into two parts. The first part is flag bit. The 0 to 9th bit contain the attribute, the information about this page table entry. And the 10th to 53-bit position, it has the physical page number. So in order to have this page number, the first thing we have to do is to perform right bit shift operation by 10-bit position. So if we perform the right bit shift operation over the page table entry by 10-bit position, we can have the physical page number. But another calculation is that this value will be the left shifted by the 12 position. So after this operation, we can have the physical address because the 10 to the 53-bit position has the physical page number. So this calculation can be represented using this pseudocode. In this pseudocode, let's suppose that A0 register has PTE, the page table entry value. This assembly instruction is performed the bit shift operation over the value of the A0 register by 10 position. As a result, the T0 register is updated to have the physical page number. The next instruction is to perform the left bit shift operation over the value of the T0 register by the 12 position. So as a result, we can have the physical address. Remember that this is the physical address. This physical address is pointing to the next level page table. This is the operation in the third step. So in this lecture, we go through the second and the third step to perform the virtual address translation. So this step is important to understand how the virtual address can be translated, because this operation in the second step and the third step will be repeated in the next level page table. Now that we understand the operation in the second and the third step, the next lecture will continue the fourth step, that is to find out the page table entry in the page table.